In the next two lessons, we're going to look at the gas carbon dioxide. First of all, we're going to look at some of its properties and characteristics, and in the next lesson, we're going to have a look at the impact that it's having on the environment. So one of the curious things about carbon dioxide, unlike other gases, is that it only exists in two states. As I say, it exists in the solid and in the gas state only. It doesn't exist in the liquid state. So here we've got two photographs of carbon dioxide in these two states. On the right, it's in the solid state. You can see it's sort of this white powdery like substance, and this is known as dry ice. Now if you take that dry ice and you add it to water, it will start to evaporate immediately into the gas state. So we can see the gas being poured out from this glass here. And this process of changing from a solid state directly into a gas state without passing through the liquid state is known as sublimation. Now then, for carbon dioxide gas to change into a solid, its temperature must be less than minus 78.5 degrees Celsius. So dry ice is actually very, very cold indeed. So if handling it, you should always wear protective gloves, and this should only really ever be done by an adult. Now the next thing we can say about carbon dioxide is that it's quite a heavy gas, right? It's a heavier gas than air. The proper scientific term really in this case is that it's a denser gas than air, but we'll talk about density when we go on to middle school. At the moment, we can just say that it's a heavy gas. In fact, if you look at this diagram here, this represents the air around us. We can see most of the particles, the green particles are nitrogen, the red particles are oxygen, and the purple particles are argon. In fact, each of these particles weighs more or less the same, but the particle of carbon dioxide is heavier than the other air particles. So, as you can see here, when it's poured out of the jar, it immediately sinks downwards, simply because it's a heavier particle. And so, as you can see, you pour it out of the jar and the particle will slowly sink downwards through the air. There we go, as a result of it being heavier than the particles around it. Now, how can we produce carbon dioxide? One of the ways in which we can do that is to add a type of substance called a carbonate, of which you will have a number of examples of these probably in your kitchen, to an acid. Right? And as a result of doing that, carbon dioxide will be released from the chemical reaction that takes place between the two. One example of a carbonate is something called baking powder. Okay, so if you take baking powder and you add it to lemon juice, for example, lemon juice is an example of an acid, or vinegar, then that will produce carbon dioxide. Another example, for example here in this particular case, I've just got some water and I'm adding an Alka-Seltzer tablet to some water. Now, the Alka-Seltzer tablet is really a mixture of a carbonate and an acid in the solid form called vitamin C. And when that tablet enters the water activates that acid and starts a reaction between the carbonate and the acid. And as a result, carbon dioxide is released. So you can see in this simple experiment, I've got a candle and I've lit the candle. And what I want to do is produce carbon dioxide. So you can do either of these ways to produce that carbon dioxide, or alternatively you can just add some fizzy lemonade very carefully to the bottom of the jar so that you don't put out the flame as you do so. So let's just put that, so you can add fizzy lemonade. So as a result of that, carbon dioxide is going to be released from the liquid into the air. All right, so gradually this jar is going to fill up with carbon dioxide. All right. As we said before, carbon dioxide is quite a heavy gas, and as a result stays in the jar. And as it does so, it begins to push the air out of the jar, including the oxygen which is helping this flame to burn. And as a consequence of this, the flame will go out. Now you can see this experiment in the practical demos section of the website, in the unit on the air around us. So carbon dioxide makes a very useful fire extinguisher. And here is a carbon dioxide fire extinguisher. Now the extinguisher contains dry ice, that's carbon dioxide in its solid state, under pressure, and as soon as that pressure is released, when I pull the lever here at the top of the fire extinguisher, the gas is ejected from the container. Now the nozzle should be directed to the base of the fire, and that carbon dioxide will then push oxygen away from the combustible, that's the material that's burning, and it will cause the fire to go out.